The training phase for naive Bayes is remarkably simple and incredibly fast. It basically involves learning two things from the training data. First, the prior probabilities, PCA, for each class, that's just counting, what percentage of the training examples belong to Class A, Class B, etc. Second, it needs the conditional likelihoods for every feature $6 and every class dollars. For discrete features, like color or yes-no, this is again just counting frequencies within each class. How often is color red when the class is apple? For continuous features, like height, we often make another simplifying assumption, typically that the feature values within each class follow a Gaussian or normal distribution. So we just calculate the mean and standard deviation for that feature for all the examples belonging to each class. That's it for training.
Wow, okay, that
Okay.
does sound fast. And then during the test phase, when a new example comes in, it just plugs the values into the formula, computes the posterior probability for every possible class, and picks the class with the highest score.
Exactly. For a new unseen test record of math BFX, we compute that proportional score, PIC, for all possible classes. We then choose the class dollar that gives the highest score. This is known as the maximum a posteriori, MAP, decision rule. And it's important to note, we can often completely ignore the denominator in Bayes' theorem, the p-procedures part, because it's the same constant value for all the classes we're comparing. Since we only care about which class has the largest score, that constant denominator doesn't actually affect the final decision, we just compare the numerators.
Okay, this brings us to the really interesting contradiction, the paradox of naive Bayes.